I'm going to ask you a project, okay? I'm not going to, there are many kinds of projects which you do. Mostly whenever we talk about project, the first thing that comes to most of the people's mind is that academic project. But here I'm asking for a project like maybe getting up from bed and coming to college. So somewhere where there are activities involved. It can be anything. Typically your construction sequence, it becomes a project, construction project. So you can choose a project of your liking which is going to be of your branch. Okay, you can just take a project of your branch and we'll try to see how we can put it in a network form, okay. So I'm just calling this a sample project. Okay, so how many mechanical engineers here, please? Wow, this is great, because in the morning class, it was mix of computer and others. I am going to just request, you're a mechanical engineer. Okay, can you think of any project of your choice?
Making a boiler.
Okay, fabrication of a boiler, that's interesting. So the project for our company is fabrication of a boiler. Okay, so can you think of activities which are there in that?
Acquiring raw materials.
Okay, acquiring raw materials. So getting raw materials. Usually we have a very nice term in management. It is called procuring raw materials. Okay, so what are the raw materials you feel are required? Steel plate, then rivets, then probably some piping. Okay, welding is probably, I'll put it under tools and plant because that should be there in the in your plant, in your workshop. And piping, then maybe some gauges. I'm not going to go too much. So gauges and instrumentation. Okay, so this is the major things you are going to procure. Okay, now next, after procuring raw materials, what could be the next step? Okay, very good. There is the design of the boiler itself. Okay, so many things have to be designed, right from the thickness of the plate till the grade of the plate to whether it's going to be welded at some point. So what are the welding techniques you're going to use? Quite a lot of design is involved, yes. Then? Yeah, actual fabrication. Now when I'm coming to the fabrication part, I'm going to say, yes. So in the shop, we'll put a few of the activities. So for example, you may need to form the shape. You may need to bend the plate. Okay. Hey guys, in my class I got a little instruction like, typically you find that after, like 11 o'clock and all that, to talk between the hostels, you find WhatsApp handy. I don't see why it should be discriminated against. You can use WhatsApp even now. Okay, I don't care whether it's within the class or outside the class. But the rule is, here you are making, if a person wants to see WhatsApp, he's going to get himself distracted. I don't mind people who are going to do it on a voluntary basis. But if you're forcing him, nudging him, please, I have something very interesting to say, that is not acceptable. Okay, so you're free to do it, but whatever it is, don't have any, it should all be only digital communication, okay? No non-verbal, no verbal communication, purely digital. Fine. Now coming to our case, in the shop, you need to do a few activities, okay? So for instance, you may need to bend the plate, okay? And then, suppose you are going to have all the seams done by welding. I'm just going to say that, the welding is operation. Then after welding, you may have some instrumentation done. Then you have also the piping which is there. Anything else is required? Probably, if suppose it is a very thick plate, you got a process of annealing. Okay, so that is also probably one of the important terms in boilers. Okay, so in fact, my brother is a specialist in welding. He works for Godrej Boys. So there, for the welding part, they bring gas in the bullets. They cannot afford to use the gas cylinder or anything because of the amount of gas you consume. So it means that if you're going to have a boiler fabricated, or any vessel for the matter, you need to understand whether the raw material, including the gas, is available for all the processes. Okay. So now I've got a set of activities which I've got. Okay, I'm not worrying about the resource as of now, but then I'm worried about the time which each of this activity is going to take. Now, don't worry about the actual time, like you don't have to be so precise about your decision about time. You can take a rough estimate as to what this time is going to be. Okay, now for the procuring of raw materials, how much time do you feel it's going to take? A week? Okay, 1 week. So here, as you were telling, we will try our best to use consistent units. If it's hours, only hours throughout, so on and so forth. So I'm going to put 7 days. Typically, working week could be 5 days or 6 days. Usually 7 days is not a working, it doesn't fit a working calendar. So I'm just making it as 6 days. Okay. So typically in a workshop, sometimes work does go 24/7, but here I'm just saying that it is a 7-day work, 6-day work week. Then next we got the design of boiler. How long do you think it takes to design a boiler? 2 or 3 days. But in all fairness, you got to get your boiler inspector to also check the design. Usually it goes for a third-party validation, but we are not worried about that. We are just assuming that we are having the designing capability to finish it in 3 days. Okay. Now let's say that this is going to be some 200 thick or 300 thick plate which you are going to use. What would be the time taken to bend the plate? 1 day max? No problem. Okay, this is our project. We can do whatever way we want it. 1 day. Then welding? 3 days. Fine. Now we got a lot of instrumentation also required. Now here there is a slight question. Do piping come first or does instrumentation come first? Piping should come first. See, this is the value of doing this. Last class I think I showed you a Gantt chart where you just put a bar chart throughout. When you are making that bar chart itself, you are going to start to think, is this sequence right or wrong? Okay, so probably this I can make it as 6. I am making this as 5. To do the piping, how long do you think it's going to take? Quite a lot of piping is there. Sometimes it may go to a few kilometers also. But anyway, not to discourage the fact, but how much time do you think it takes? Maybe another 4 days. And you got the instrumentation also to be done. That could be 2 days. Okay, fine. Then you got the actual, the boiler is finished. You may have to do some annealing, okay, some heat treatment to relieve all the residual stress. So this, I guess, it's going to be a 3 days affair. So this is the first step which we are doing in when you are trying to construct a sequence of activities. You are trying to construct a sequence of activities, and this is probably the first step which we are doing. Okay, now let me just think about all of this. Does this look reasonable? It looks reasonable. Do you think any more activity is required? Do you feel anything else should come? So this is a good time to think about it, because if you don't think about it now at the stage of planning, it may even get missed out altogether. Okay, so one thing you will notice, to be able to successfully schedule, you need to have some basic idea of the work which you are doing. Okay, this is the value of what we have as the experience. Okay, now I am just going to make it very rapidly. Okay, so here I am procuring the raw materials. I am putting this as procurement. I am just putting it as procurement. And we've got 3 days. We say that it is 6 days affair. Okay, now it's a 6-day affair. In your opinion, do you think procurement and design can go hand in hand, or should design be done first before procurement? Both can be done at the same time, because if I don't do it at the same time, you will find that you are going to extend the project unnecessarily. So that means after these 6 days are over only, I will be starting the next job. To avoid that, I can as well start doing it right now. So I put it as design. Now my design only takes 3 days. Okay. And so on and so forth. We got the rest of the stuff. Now, where will bend the plate come? After procurement. Okay, I just cannot start this before I finish my this one procurement. Now there is a slight problem. I need also to design the various parameters before I start to bend the plate. But then there is nothing, no activity between these two that join them, right? There is nothing which I think of an activity to join them. Now this formulation is called as the activity on arrow. If I am having an activity only, I can put an arrow, but in this case there is no activity. So what am I going to do? I am going to put what is known as a dummy activity. Now what happens when I put this dummy activity is, it says that there is a relationship between these two nodes. This node can only be started after both this one and this one, these two activities are completed. Here I don't allocate any time. No resource will also be allocated to it. No cost also need to be allocated to a dummy activity. But the dummy activity helps you to keep the project flowing in the correct sequence. Another thing is, I could have put this bend pipe here also. Okay, I don't see any reason why I shouldn't have done it, because this bending of the pipe cannot start till I finish the design. So now you see there comes a slight situation, a crisis like situation, because I find that I could have kept it in either of the places. I could have kept bend plate here also as a link from this node also. So this is over, this is so on and so forth. So we got the rest of the stuff. I got bend the plate, then I go for the welding. I cannot definitely do the welding before I finish the bending of the plate. So I go for welding, and welding welding is a 3-day affair. And about instrumentation, I know I cannot do it before the piping is done. Okay, so probably after welding is done, I go in for the piping for this particular boiler. So I put piping over here. Excuse me. So I put the piping over here, and after this I have got the instrumentation. Okay, I have got the instrumentation. Now I got this interchange, and any other thing which I can probably play around, not in particular. So then once I have the instrumentation done, another option is there. As I do the piping, okay, there is a chance that I could do the instrumentation also, right? So when I put a pipe, I might need to put a gauge before I close up the boiler shell fully. So now if you are with me, I could make another loop like this. I could branch it off here and say instrumentation and piping may need to go at the same time. Okay, so you will find that you are taking a lot of decisions at the time of doing your project. Okay, sorry guys, if I have this ability to rub it just like that. If you have done it, you can just leave it like that. It is just a sample. But in any case, here again I come to a situation where I need to keep the flow right. I cannot do the heat treatment till I finish the whole thing, I presume. So I keep it and then say heat treatment or testing, whatever you want to put it right here, and then the project finishes here. Okay, so here the problem is you need to choose dummy activities. You need to choose dummy activities. This type of representation of the project network is known as the activity on arrow. Okay, this is called as the activity on arrow formulation. Now, computer programs don't like this. They prefer what is known as the precedence diagram or the activity on node. You write the activity on the node. The benefit of activity on node is you will not need to use any dummy activities, because the activities are put on this one on the node, and you can connect any number of arrows which you require. Typically, I prefer that the activity on node is made on a box like this. The activity on node is made on a box like this. So here you will give the activity name. Then we have the early start time, EST. Here usually typically you put the duration. Then here you got the early finish time. Okay. Then again you got another thing. Here you got the late finish time, late start time. Then you got what is known as the float. Okay. Now if I look at this sequence, I find that procurement and design are going hand in hand. Procurement and design go hand in hand. Okay. Now for instance, if you look at it, you got quite a lot of procurement to be done: steel plates, rivets, piping, gauges, instrumentation, so on and so forth. We've identified it. Now let me put this on a linear scale. I'm going to put this on a linear scale. Okay, so what I'm doing is I got a graph where I'm going to put the number of days. So I got maximum number of days is 6. 1, 2, 3, 4, 5, 6. Okay, so this is day 1, day 2, day 3, day 4, day 5, day 6. Okay, so what I'm deliberately doing this from 1 in the origin, and here if you see, if I'm going to put this as a graph, procurement would look something like this. When I'm going to do the procurement, I start from here, and this is going to be the length of the activity. Okay. After this, I got another activity called design. Design takes only 3 days. But the next activity cannot start till both these activities are completed. Okay. So this 6th day marks the finish of both the activities. 6th day marks the finish of both the activities. Guys, probably I should have started with 0. Okay, I should have probably started with 0. So I'm just leaving it like this for now. Now 3 days I'm going to keep for design, and I probably want design to complete like this. I can keep the design so that it starts in this manner, or I can plan the design so that it can start from here. Okay. Now which of these two do you think is more preferable? So this is where your judgment comes into the picture. Okay. See, for instance, if I were addressing a classroom of civil engineering students, here what happens is, whenever I'm having a resource like bar benders are very important, because only after they do the reinforcement rods, whatever you see in the structure, you can pour your concrete, right? So you will find that you need those resources, but you will not be able to play around too much with them. Okay, so here in this case also I am keeping it in that particular fashion. Okay, now just a minute please. Okay, while I wait for the slide sorter to get in, I'll just come to what we need to do here. Now what we are going to do is, we are going to go for a precedence diagram or an activity on node. We are going for an activity on node. Okay. So here, what is the first activity that we have here? Procurement. I must confess that in the previous class I had a much more interesting this one. Here I was trying to get the assembly of a car. So we had 3 activities which we told started at the same day: engine block manufacture, transmission emission system and suspension system. So again I try to do the same thing. Here what happens is, you got this engine block having 4 days, okay, and then we had a transmission only requiring 1 day, and the other thing suspension system 3 days. So here what happens is, if you look at it, you are able to see that these 3 activities could be placed in a lot of places. Okay. Now I will come back to this example, but here what I want to tell is, when I do the design, we are restricting ourselves to the start, okay, because we know that it's more desirable to do it at the start. But in this particular case, this transmission could have been fabricated at any point from the start till end. Anyway, only after the engine block is complete, I am going to be able to mount the transmission. So that is my argument here. And anyway, coming back to our case. So here we are having this procurement. What is the duration of procurement? 6 days, right? Okay. Procurement is 6 days, and the design is the design is a 3-day thing. Okay, the design is a 3-day thing. Now actually what happens, or the point we are trying to make is, I got a free time between the design and the procurement. Okay, design and procurement. It means, suppose I got a non-critical design. If I got a non-critical design, then I can try and shift this to any place between these 2 lines. This line will be called as the early start time. This line will be called as the early start time, and this will be called as the early finish time. Early finish time. Earliest I can start this activity at this point. I can finish this here, because if I delay this, if I move this from early start time, the next activity is going to get affected. The next activity is going to get affected. On the other hand, if I look at this design, this one which I am putting in red, the one in red, I can even start it at this point. I can even start it at this point in time. But then what would happen? The end date will still be the same. So if I don't want to delay the project, I can still start it at this green line. This line is what we call as the late start time. Okay, this green line is what I call as the late start time. Okay, and this will be the late finish time. This will become the late finish time. Okay, so is this concept okay? Is it clear to you? So I can start this activity either on this point in time. That is the earliest I can start this activity is here, because the customer or the owner is telling you, your boss is telling you, start the work on such and such day. For example, start it on 22nd of March. So you cannot start it on 21st of March, because if you do it, I mean, you are not supposed to do it. So this becomes the early start, and then if I add a duration, it will come to a point which is the early finish time. Now there's one observation which I'd like you to make. Whatever I do, this is not governing the finish time. This is not governing the finish time, because this has the longest duration. This activity has procurement as the longest duration. So what happens is, this activity determines all the activities before this point in time. This activity determines all the activities before this in time. Okay, so you will just come to understand that it lies on the critical path a little later. Okay, but as of now, just make that observation. So now we've got the other thing designed. So we are saying that both of these start at the same time, and then we go for the bending of plate, which we have taken it as 1 day. So I'm just putting bent plate, and yeah. Okay, now coming here, I'm saying that procurement starts on day 1. Earliest I can start procurement is day 1. Okay, same thing. The earliest, when can I start design? Earliest I can start design on day 1. Okay, now I prefer to use the calendar method of counting. Okay, because that's what the software tend to do, and that is the way you practically work. Okay, maybe you'll find it as a little discrepancy in what I got in and maybe what's in an OR book. They may start with 0 and then go on, but I prefer to start with the 1 and say that is day 1 or first hour or first minute. What is the unit of time? We'll consistently use it. So if I'm going to go with days, when will this procurement activity get over? It will finish on 6. That is first, second, third, fourth, fifth, sixth. Okay, so earliest I can finish is on 6th day. Okay, now when will the design get over at the earliest? 3. Okay, great. Now I come to this bending of plate. When can I start it? 7th day. 6 days are finished. Okay, I go for the next day, next available calendar day, which is 7. Okay. Now this, how many days does bending the plate take? I think 1 day only we put, right? Yes. So if I start it on 7th, I finish it in 1 day. So when will the early finish be? 7. Today itself it's getting over. Today morning I started, by today evening I finish it. Okay. So then this becomes 7. Okay, 1 day, this becomes 7. After I finish the bending of plate, I go for welding. Now welding takes 3 days. Again, this is a straight relationship, so nothing to worry about. But here what I do, I take an arrow, connect it like this and say this is the direction of flow of work. So here I got welding. And what is the duration of welding, please? 3 days. Okay, now what happens to welding here? When does it start? And when does it get over? 10th. Okay, so then we branched again here. Piping and instrumentation, we are saying, goes hand in hand. So I'm just connecting it here. Now what happens? Piping. When does piping start? 11th day. What is the duration? What is the duration here? 2 days. So 2 days. So then this becomes 12. And instrumentation. Instrument piping is 4 days. Instrumentation is 2 days. So what I'll do, take the easy way out. I'll make this as instrumentation. Okay, so then I got again after instrumentation I got piping, which is 4 days worth of work. So here this will start again on 11, 12, 13, 14, and after this we do the annealing or the testing, whatever, that takes another 3 days. Okay, So then I again connect this with arrows and get it here and say I'm just putting it as testing, and we are having it as 3 days work. Right. Now when does this boiler, like how many days by this chart does it take for the, now yeah, by the way, what is for testing, what is this early start for testing? 15. Okay, so because I can go only for the next calendar day, 15, 16, 17. Okay, so 15, 16, 17. So if I'm not envisaging any delay, the project is going to get over on 17th day. The project is going to get over on the 17th day. And now I'm just thinking a little differently. Like, let us see what happens to the back pass. Now what we're going to do is the back pass. This will help us get a lot of things. So here what I do, earliest I can finish this task, latest I can finish this task is 17th day. See, if suppose you want to finish this task much later, that is also possible. You may have a strike, you may have some delay. 17th could become the 20th also. But now we are only talking about the ideal condition where there is no problem, everything is going to our planning stage. Okay, at the planning stage you put 17. Now again we are having 3 days delay. So 17 minus 3, 17, 16, 15th day. Okay, now when I come here, the latest I can finish this is 15th day, I'm sorry, 14th day, the day before this, 15. So the latest I can do this is 14. Same thing applies here also. 14 minus 4 days, 11. Now here, 14 minus 2 days, 14th day minus 2, 13th day. Okay, so I come here, I get 13. Now I have 2 days, or the latest I can finish, okay, is, right, latest I can finish is, here is 10, 10th day. 11 is there, so 10. So 10, 8, here again, okay, so again 7, 1 day 7. When I come here, I get procurement as 6 and I get design as 6. 6 minus 3, 4. Okay, so yeah, 4. Now we are going to compute how much of free time this activity has. Now let's come back to this bar chart. Here if you see, there is no free time at all, right? Both the sides, I cannot delay this activity. If I delay the activity, the entire project schedule is going to get affected. Okay, so here what happens is, the early start, okay, float or slack or whatever, so many words are used. The free time which you have is nothing but the early start time minus late start time, or early finish time minus late finish time. Okay, this is not the same as the duration which you have. So when I do the float, I find that there are certain activities where the float is 0. 6 minus 6, 0. 1 minus 1, 0. 6 minus 3, that's something else. So here again I get 7 minus 7, 0. 10 minus 10, 0. This is not 0. I get here 14 minus 14, 0. 17 minus 17, 0. So these activities do not have any free time. Okay, these activities do not have any free time. If there is a free time, okay, then you call that, it is having a float, and the float here is 6 minus 3, 3 days. That means I can play around with this activity for 3 days. If I do it, I will not affect the duration of the project. Same thing appears here also. 14 minus 12, 2 days. And other activities are all on the critical path. All the other activities are on the critical path. Okay. Now I'll just probably okay, my slideshow is still in distress. Okay. So right. Right. So if you look at this, slide, you will find that there are certain activities for example, the first activity, like a design, you could move it wherever you want, little. Okay. So such activities have a float. Okay. So the thing about this is you can either keep it at the last or you can keep it at the beginning. Okay. So if you look at this, essentially I want you to just know that you can have a float whichever way you want. This is in your control. You can allocate resource based on your availability. So perhaps if I keep it here, you may not have that particular resource. Okay. So resource means maybe a design engineer or somebody. So what you can do, you can move this activity in such a manner that you still can use your resources in an optimal fashion. But for when the activity is on the critical path, you don't have that luxury, unfortunately. Okay. Now I will wrap up this lecture here. In the next class, I will be opening MS Project. Okay. And you can get MS Project free of cost if you register for the DreamSpark program on VIT. DreamSpark at vit.ac.in is the website where you need to send in your request. Send in your request to DreamSpark, DREAMSPARK at vit.ac.in. Okay. They'll send you an email which might wind up in your spam folder. Sometimes it may wind up in your social folder, or it may, if you're lucky, it will wind up in the inbox. It may take 1 or 2 days for them to also send in this request, but typically I find that they respond immediately. Okay. Immediately in the sense within 1 working day. Now, when you get this, it's just like in Flipkart, you can go and download any of the software which is there. If you're in the computer IT field, maybe you've already got yourself registered for it. Microsoft Project is there. Get your licensed version, you'll get a license key, download it from the site. Okay. Probably if one of you download, you can share it with among yourselves. Okay. But don't share the key outside our university. Right. So we'll do the same thing on MS Project and see how it works. Okay. I will be coming again on Monday only, sir, next. Okay. So Monday we'll try our best to start at 2 p.m. No, what is it? What time is it? Monday? 2 p.m. We'll start at 2 p.m. sharp. Okay. Thank you so much for coming. And if you do you have any doubts in what you have seen, any clarification? Okay. If you have, you can still meet me at a later time. Okay. Thank you so much.